let's draw this out. You could just, I'll put that on the video somehow, so you don't have to record that. All right. So first he walks 8 kilometers north. So we say the clown started here, and his first displacement was 8 kilometers north. And then the next one, he's going to go east of north, 35 degrees. So what you want to do is you want to figure out, this is still the north direction, and he's going to go to the east of north. So he's going to go that way, 35 degrees. So you want to come over 35 degrees. So that's about 35, we'll say. And he's going to walk 3.5 kilometers. So it's 35 degrees. The second displacement is 3.5 kilometers. And then lastly, once he's at that position, he's going to walk due east. So that's directly east for another 5 kilometers. So there's that. That's the displacement vector 3 is 5 kilometers. And those 3 vectors are arranged tip to tail. So now we could draw in our resultant from where we started, the tail of the first vector to the tip of the last vector. And that resultant tells us that instead of doing this three displacement route, he could have just done that. Started here and walked there. And what we want is, what is this length and in what direction is it? And we're using the component method, right? So what we need to do is consider the components of each vector. And then, so break them down, resolve it, and then ultimately find dr in the x direction and dr in the y direction. And then they're at a right angle to each other, and we can do Pythagorean theorem and use a trig function to get the direction. So drx is going to be the sum of the components in the x direction. So we have d1x plus d2x plus d3x, or the x component of each of those vectors. And dry is going to equal d1y, which is the y component of vector 1, plus d2y plus d3y. Okay, so let's start with the x's. What is d1x? So the clown was here, he walked directly upward, and at that point I yell out to him, what is your x component? What does he say? Jackson. His x component? 0. Right. So that's 0. And now he turns and he walks over here. Now he's here. And I yell out, what is the x component of your second vector? Well, let's visualize that. So there's the y component and there's the x component. So we have a right triangle. So we want to find x. So how can I find x there? Sine function, right? 35-degree angle, so we want the side opposite. So sine of 35 is x over the hypotenuse, which is 3.5. If we solve for x, that's 2. So now we know that this x here is 2, so the x component is 2. And then d3 in the x direction. So now he walks this way, and he's here. What is your x component of that vector? Garrett? 5. And so the total x is 0 plus 2 plus 5. So that tells me the length of drx. So you add those together, and you get 7. So that means he walked a total of 7 in the eastern direction. Now we do the same thing for dry. So d1y is, it's all y, right? So what is it, Alex?
So d1y?
Yeah.
Isn't that sine Nah, didn't I screw mine up and I used 55 instead of 35?
Well,
Or-
you did that for vector 2. Let's look at vector 1. I'm just asking you
Okay.
what D1y is.
D1y is 8.
8. Now for D2y, since we're on you, yeah, you mixed them around yesterday.
Yeah.
So if this is our angle, we want this side, we want the adjacent side. Right?
Yeah.
So we're going to do cosine. So cosine 35 is y over 3.5. So y is 2.9. So that means here is 2.9 for y. And then what is the or the y component of vector 3? Brian. X component of this vector? 0. So now we know the total y is 8 plus 2.9 plus 0 is 10.9. So we know this is 10.9.
Can you grab me a
So
piece
it's-
of tape?
What's the matter?
Piece of tape to hold it up because it's not holding itself up anymore. Alright,
Thanks,
so
Alex.
I'll deal with that.
So instead of the clown going 8, turning and going 3.5, and turning and going 5, he could have just, if we limited his motion to x and y, he would have done this and that. So let's figure out, if we didn't limit his motion, he wanted to take the most direct route, he would just do dr. So that would be the equivalent of going 7 to the right and 10.9 up. So that gets him where he needs to go. So what we want to do is find this length and this angle. So to get the length of dr, we do Pythagorean theorem. So 10.9 squared plus 7 squared, take the square root of that, get 13. So dr is 13. That is the magnitude. And then theta, we can use any of our trig functions since we have all sides. I'll do the inverse tangent. So that's tangent to the negative 1, 10.9 over 7. And that gets us our, I forget what it is. Right, 57 degrees. So this is 57 degrees here. And that was, if that's the eastern direction, we came north of east. So your final answer would be 13 meters at 57 degrees north of east. Anybody have questions on it? Josh?
If he was like initially oriented going north and then veered east, how come it's not east of north?
Well, we could say that. We could, if we wanted to find this angle instead, we would say 33 east of north. So all we know is, let's just picture he's standing here. And then if I want to do it this way, he's got to figure out which way is east and then turn. If I tell him go the other way, then he wants to make sure he's pointing north first and turn. Okay. Other questions on